And welcome back. We're back to our critical render path diagram. It's slowly starting to make sense. We've talked about HTML and CSS. Now we're going to talk a little bit about JavaScript and before it gets into the rendered tree. Now, out of HTML and CSS, I think JavaScript is probably the worst because it can access and change both the DOM and the CSS DOM. This means that once a script tag in the HTML is discovered, the DOM construction is paused and the script is requested from the server. So no matter what we're doing in the HTML, we see a script file, we need to go request it. Once the script is loaded, it can't be executed before all the CSS is fetched as well. And the CSS DOM is constructed. After the CSS document object model is constructed, JavaScript is executed. And yes, as you can imagine, JavaScript can and may access the DOM as well as the CSS DOM, and it can alter it. And only once that is done can the page finally be rendered by going to the render tree, layout, and paint. And that's why we call JavaScript a parser blocking. Remember the alert code that we did before, where we had a script tag with alert and it just completely blocked the page? Now with JavaScript, there's a few things that we can do to optimize it. Let's start with the first one, loading scripts asynchronously. And to help with that, I have a nice little diagram for us. You may have seen the most common way of having script tags, which is, just script. When the HTML starts reading, which means parsing the file, it's going to encounter a script tag. And this script tag needs to get downloaded, which blocks the HTML parsing. It also needs to get executed, which blocks the HTML parsing. And then finally, once that's done, the HTML is back to being parsed. Now we have two new properties that we can add to our script tags to alter this behavior. And the first one is async. So loading scripts asynchronously. And that's right, it's super simple. All we do is add this attribute to our script tags. By using async, we can tell the browser, go ahead and download the JavaScript file with another thread. Think of a thread as a person doing work. He or she can only do one thing at a time. With async, we can say, hey, to another worker, while I'm working on this HTML parsing, can you go download the JavaScript file? And this JavaScript file is now downloading on a low priority, but it doesn't block the rest of the page loading. And as soon as it's finished downloading, it will execute. So that part, it's still blocking the HTML parsing. Now, there's a catch to this. This means that it can execute at any time, which leads to two obvious issues. First, that it should execute long after the page actually loads. So for example, if we're relying on this async script to do something with our user experience, then we may give our user a suboptimal experience. Second, if it happens to execute before the page finishes loading, we can't really predict if we need access to the DOM or some of the elements. If it starts doing some DOM manipulation without the actual DOM being there, well, we might get some errors. So here's the rule. With async for scripts, add them to anything that doesn't affect the DOM or the CSS document object model. So async should be used for pretty much all external scripts that require no knowledge of our code and are not really essential to our user experience. You can think of this as maybe Google Analytics scripts or tracking scripts. Now, there's a second option. And again, going back to our point here, the other option with JavaScript is that we can defer loading of scripts. And defer loading of scripts, again, is simple with this one attribute. Defer is very similar to async in that it will not block loading of our page. However, it will wait to execute until after our HTML has been parsed and will execute in order of appearance. As you can see here, it's going to wait until HTML is completely parsed and then start executing. Now, this is really good option for scripts that will act on the render tree or the DOM. But they're also not important to loading maybe the above the fold content. So here's my rule for when to use async and defer. If the core functionality requires JavaScript, well, async is best. If core functionality does not require JavaScript, then JavaScript should be deferred outside of the critical render path. Your critical scripts, your app script should be here. Third-party scripts that don't affect the DOM should be here. And any perhaps third-party scripts that aren't that important, aren't above the fold, should use defer. Let's look at the other options. We can minimize DOM manipulations and avoid long-running JavaScript. So let's use an example here to demonstrate this. We've upgraded our site a little bit. We've added a button with red font this time and a cute little dog picture. And the file here, again, it's a pretty basic file. We have a new image tag here now, and we have a couple of scripts. And don't worry, I'll give you access to all these files at the end of this section so you can start practicing as well. Now, in here, in the script tags, you see we have a few things. One that we're going to talk about is the first one, which is an inline script tag. And this script tag simply grabs the button on our page and adds the style color red. Let's see what happens here. When I refresh the page and take a look at the button over here, as I'm refreshing, let's do hard refresh, there you go. You see that the button is always red. At no point, if I remove this, let's say this is just going to be the default, which is black, because JavaScript gets executed before the render tree, just like here, if we remember our diagram, once our JavaScript is loaded, it's going to read, the browser is going to read inside it and see if it needs to load any more things. So once again, you can imagine here, if you're modifying the DOM or changing the styles, that's just extra work that the browser has to do to render. Let's take a look at these other script files that I have here. Well, this is the first script file, which I've added a couple of event listeners to. One is DOM content loaded, and the other one is load. And I'll explain what those do in a bit. And then finally, we have this is script 1. For now, let's just look at this script file. I'm going to comment out the script 2 and 3, save, and I'm going to open up the developer tab here, and I'm going to refresh. All right. Let's see what just happened here. We have this is script 1, DOM fully loaded and parsed, and then finally all resources finished loading. If we look at our file, we called the script file. What happened here first? Console log, this is script 1, was called first, before DOM content was loaded, before the page was loaded. So the browser checks the scripts to make sure that it has everything it needs to build the page. And if we open up the network tab here and I refresh again, I see that the blue line, which is over here, is the DOM content loaded, which took 14 milliseconds, quite fast. And that says that the document object model has been loaded. And then finally, load, which is the red line over here, says that all the content on the page, including this image, has been loaded. So because of the way the critical render path works, what happens is that we're reading the JavaScript file, building the DOM tree, finally finished building it, and then finally finished loading all the scripts or all the files, including the image. So if we go to our script 2 and script 3, as you can see, very simple, just console logs. If I add them into our page and I refresh, let's go to the console and we see that we have 1, 2, 3, DOM fully loaded and parsed, all resources finished loading. And just for fun here, let's add an async attribute to script 2. If I refresh, look at that. Async or asynchronously downloaded script 2 now loads after the DOM is fully loaded because it's not blocking it anymore. Very, very cool. All right, the last thing I want to show you is the avoid long-running JavaScript. And this is something that we'll talk more about in part 2 when we talk about optimizing code. I do want to show you one point. If we go back to our code here, I have another script, and this script simply adds an event listener, click, that has an alert, stop clicking me. And let me show you why long-running JavaScript files or long executing JavaScript files are not a good idea. You see, right now, this page, it's not too much loading, but let's just move it up a bit. So I can scroll here. That's great. If I click on here, oh, and I should remove the first one because they'll complain that button already has been declared. If I refresh here, see that the button's not red anymore. If I click, I can't do anything anymore. I can't click anymore. I can't scroll anymore. The page is completely blocked because this JavaScript code is running. So if you have JavaScript code that is executing for a long time, well, you have pretty poor user experience because it feels all blocked and janky. All right. There you have it. We now know how the HTML DOM is constructed. We know how the CSS object model is constructed. We know how JavaScript is read and executed. We know when DOM content is loaded. We can finally do some other things. And finally, we know that when the web page is completely loaded, we get that load event. So in the next video, let's talk about these last few steps and get into some exercises. I'll see you in that one. Bye-bye.